Or what if I told you there are mysteries in our solar system that even the smartest scientists can't explain? That's right, our cosmic neighborhood is filled with enigmatic puzzles that defy our understanding. From the bizarre hexagon storm on Saturn to the unexpected magnetic field of Mercury, each planet and moon holds secrets that are waiting to be uncovered. In this video, we're diving deep into the most perplexing, spine-tingling unsolved mysteries of our solar system. So stick around, because by the end of this journey, you'll be questioning everything you thought you knew about space. Get ready for an adventure that's out of this world. The disappearance of planet Vulcan involves a historical enigma that has puzzled scientists for centuries. In the mid-19th century, astronomers observed peculiarities in Mercury's orbit. French mathematician Urbain Le Verrier hypothesized the existence of another planet, which he named Vulcan. Vulcan was thought to orbit closer to the Sun than Mercury, its gravitational influence supposedly explaining Mercury's orbital anomalies. Several amateur and professional astronomers claim to have seen it, sparking considerable excitement in the scientific community. However, despite numerous searches, Vulcan was never conclusively observed. The mystery deepened until Albert Einstein's theory of general relativity offered a new explanation. According to his theory, the anomalies in Mercury's orbit were caused by the curvature of space-time near the Sun, not by a hidden planet. This revelation effectively debunked Vulcan's existence, yet it remains a fascinating chapter in astronomical history. The story of Vulcan underscores the evolving nature of science, where theories are continually tested and retested, sometimes leading to surprising conclusions. While Vulcan may not exist, its tale is a compelling reminder of the mysteries that the universe still holds, waiting for us to uncover. The second mystery involves the Strange Hexagon on Saturn. This gigantic hexagon, located at Saturn's North Pole, first captured our attention when it was discovered by the Voyager spacecraft in the early 1980s. Measuring over 20,000 miles across, this geometric feature is unlike anything else we've seen in the solar system. Scientists have been baffled by its precise six-sided shape. Some theories suggest that the hexagon is formed by a standing wave pattern in the planet's atmosphere. Essentially, this means that the atmosphere's fluid dynamics create waves that interact to form this stable hexagonal structure. Others speculate that differences in Saturn's cloud speeds contribute to this uniquely shaped phenomenon. Despite numerous observations by the Cassini spacecraft, the exact cause of the hexagon remains a puzzle. Is it influenced by subsurface structures or magnetic fields? These questions are still open for debate. What adds to the mystery is the hexagon's ability to persist for decades, maintaining its shape despite the tumultuous weather patterns that characterize Saturn. This enduring enigma invites further exploration and reveals yet again the wonders of our solar system. As we continue to study Saturn and its iconic hexagon, we may someday uncover the secrets behind this incredible atmospheric anomaly. The third mystery involves Mars' Recurrent Slope Lineae. These dark streaks appearing on Martian slopes during warmer seasons have intrigued scientists since their discovery. They seem to flow down steep slopes, creating narrow channels that can stretch for hundreds of meters. Initially, these streaks sparked excitement because they were thought to be a sign of liquid water on Mars. If true, this discovery would have profound implications for the possibility of life on the red planet. Some scientists propose that these streaks were caused by salty water, which can remain liquid at lower temperatures. However, subsequent research has muddied the waters. High-resolution images and spectral data suggest that the streaks might not be due to water at all, but rather dry flows of sand and dust. The exact mechanism behind the formation of Recurrent Slope Lineae remains a topic of intense debate. Are we witnessing the seasonal melting of subsurface ice, or is this a purely geological phenomenon with no connection to water? The mystery deepens with every new piece of data we collect, leaving us with more questions than answers. As our exploration of Mars continues, the true nature of these enigmatic streaks may eventually be revealed, shedding light on one of the planet's most intriguing features. Until then, Mars' recurrent slope lineae remain a tantalizing puzzle, emblematic of the red planet's many secrets waiting to be unlocked. The fourth mystery involves the Great Red Spot of Jupiter. This massive storm, larger than Earth itself, has been raging on Jupiter for at least 400 years, possibly even longer. First observed through telescopes in the 17th century, the Great Red Spot has become one of the most iconic features of our solar system. But why has this storm persisted for so long? Scientists are still trying to unravel the secrets behind its longevity. One theory suggests that Jupiter's lack of a solid surface allows storms to last much longer than they would on Earth. The planet's internal heat might also play a role, providing a continuous source of energy to fuel the storm. Another idea points to Jupiter's rapid rotation, which might help sustain the Great Red Spot by creating strong wind currents that circle the planet. Despite these theories, many questions remain. For instance, why is the spot red, and why does it seem to be shrinking in recent years? High-resolution images from spacecraft like Voyager, Galileo, and Juno have provided valuable data, yet the exact dynamics of the Great Red Spot are still not fully understood. It's an enthralling mystery that keeps astronomers and planetary scientists busy with endless fascination. As we continue to study Jupiter and its enigmatic storm, we hope to uncover the mechanisms that allow the Great Red Spot to persist, offering new insights into the atmospheric dynamics of the largest planet in our solar system. The fifth mystery involves Enceladus Mysterious Plumes. These incredible features were first discovered by the Cassini spacecraft in 2005 and have since captivated scientists and space enthusiasts alike. Enceladus, one of Saturn's moons, emits giant plumes of water vapor and ice particles from its south pole. These plumes shoot out from fractures in the moon's icy surface, often referred to as tiger stripes. The big question is, where is all this water vapor coming from? Some researchers believe these plumes are evidence of a subsurface ocean beneath Enceladus' icy crust. If true, this would be a monumental discovery, as such an ocean could potentially harbor life. The presence of organic molecules detected in the plumes adds to the excitement and the mystery. How is the water heated to such an extent that it erupts into space? One theory suggests that tidal forces from Saturn's gravity create frictional heating within Enceladus, keeping the subsurface ocean in a liquid state. Another idea is that hydrothermal activity on the ocean floor generates enough heat to drive these plumes. Despite numerous flybys and detailed observations by Cassini, the exact mechanisms behind the plumes remain elusive. Are they influenced by geothermal processes similar to those found in Earth's deep oceans? And what does this mean for our understanding of habitability in the colder regions of the solar system? As future missions to Enceladus are planned, hopefully, we will uncover the secrets hidden beneath its icy shell, providing new insights into this fascinating moon and its potential for life beyond Earth. The sixth mystery involves the Huygens Crater on Mars. This massive crater, named after the Dutch astronomer Christian Huygens, stretches over nearly 280 miles across the Martian surface, making it one of the most prominent features on the red planet. What makes the Huygens Crater so peculiar are the unexplained features found within it. For starters, the crater's rim and interior are heavily eroded, suggesting that it is ancient, possibly dating back billions of years. However, the surprising part is the presence of valley networks surrounding the crater. These networks resemble river valleys on Earth, indicating that liquid water might have flowed here in the past. This leads to the tantalizing question: what caused this erosion and the apparent flow of water? Was it due to ancient Martian rivers, or perhaps even rainfall in Mars' distant past? Adding to the enigma are the unusual deposits found at the crater's center. These layered sediments suggest a complex geological history, possibly involving volcanic activity, or even the presence of a lake that once filled the crater. Some scientists speculate that these sediments could hold clues about the climate and environmental conditions on early Mars. But despite multiple missions and detailed photographic surveys, the exact history and formation processes of Huygens Crater remain elusive. Was it a site of volcanic eruptions, or did a massive impact create these features? What do the sediment layers tell us about Mars' past climate and the possibility of ancient life? These unanswered questions make the Huygens Crater a focal point for ongoing research and exploration. As future missions to Mars aim to uncover more about its history and geology, the secrets of the Huygens Crater may eventually come to light, providing valuable insights into the red planet's enigmatic past. The seventh mystery involves the dark side of the Moon. Contrary to its name, the far side of the Moon is not permanently dark. It is simply the side that never faces Earth. This hidden hemisphere has intrigued scientists ever since the first images were captured by the Soviet Luna 3 probe in 1959. One of the most remarkable features of the far side is the stark difference in terrain compared to the near side. While the near side is dotted with large, dark plains called Maria, formed by ancient volcanic activity, the far side is heavily cratered and lacks these extensive basaltic plains. Why this asymmetry exists is still unknown. Some theories suggest it could be due to the Moon's tidal locking with Earth, which caused uneven heating and cooling over billions of years. Another mystery is the presence of a massive impact basin known as the South Pole Aitken Basin. This 600-mile wide and 8 miles deep basin is one of the largest and oldest impact craters in the solar system, yet its formation and the events that followed remain a puzzle. Adding to the intrigue are the recent discoveries made by China's Chang'e 4 mission in 2019, which landed on the far side for the first time. The rover found signs of minerals that are part of the Moon's mantle, suggesting that the basin might have exposed deeper layers of the lunar crust. This finding raises more questions about the Moon's geological history and the processes that shaped it. Moreover, the far side is also an excellent place for radio astronomy, as it is shielded from Earth's radio noise. However, the lack of direct line of sight for communication poses significant challenges for exploration. As technology improves, future missions to the far side may reveal more about these enigmatic features, helping us understand not only the Moon's past but also the broader history of our solar system. Until then, the dark side of the Moon remains one of the most intriguing and mysterious regions waiting to be explored. The eighth mystery involves Neptune's vanishing storms. Neptune, the eighth planet from the Sun, is known for its incredibly dynamic and turbulent atmosphere, characterized by violent storms that can last for years. One of the most famous storms is the Great Dark Spot, which was first discovered by the Voyager 2 spacecraft in 1989. This storm was similar in size to the Great Red Spot on Jupiter and was a prominent feature in Neptune's atmosphere. However, when the Hubble Space Telescope observed Neptune a few years later, the Great Dark Spot had mysteriously disappeared. This phenomenon was both surprising and puzzling to astronomers. Since then, several other storms have appeared and vanished on Neptune. For example, in 2018, Hubble detected another large storm in Neptune's northern hemisphere, similar in size to the Great Dark Spot. By 2020, this storm had started to drift southward and shrink, and it eventually disappeared. The disappearance of these massive storms raises many questions about the atmospheric dynamics of Neptune. Why do these storms appear and then suddenly disappear? Are they influenced by the planet's internal heat, its rapid rotation, or perhaps by some unknown atmospheric processes? One theory suggests that these storms are formed by huge upwellings of gases from deep within Neptune's atmosphere, similar to the way thunderstorms form on Earth. However, the mechanisms that cause these storms to dissipate so quickly are still not well understood. The rapid disappearance of these storms challenges our understanding of the atmospheric conditions on Neptune. It suggests that there may be complex and rapid changes occurring in the planet's atmosphere that we have yet to fully grasp. Moreover, Neptune's storms are not just a local phenomenon, but are part of a larger pattern of atmospheric circulation that includes strong winds and jet streams. Understanding these storms could provide insights into the overall climate and weather patterns of the planet. As we continue to observe Neptune with advanced telescopes and possibly future missions, we hope to uncover the secrets behind these vanishing storms. These discoveries could not only help us understand Neptune better, but also improve our knowledge of atmospheric processes on other planets, including our own. Until then, Neptune's disappearing storms remain a captivating mystery in our solar system, highlighting the ever-changing and unpredictable nature of this distant ice giant. The ninth mystery involves the formation of Uranus's extreme axial tilt. Unlike any other planet in our solar system, Uranus is tilted on its side with an axial tilt of about 98 degrees. This means that Uranus essentially rolls around the Sun on its equator, with its poles alternately pointing directly at the Sun. This peculiar orientation leads to extreme seasonal variations, with each pole experiencing 42 years of continuous sunlight followed by 42 years of darkness. The big question is, what could have caused such a dramatic tilt? One prevailing theory suggests that a massive collision with an Earth-sized protoplanet might have knocked Uranus onto its side. This giant impact hypothesis is supported by computer simulations that show how such a collision could result in the planet's current axial tilt. However, this theory leaves some questions unanswered, such as why Uranus's moons and ring system also share this extreme tilt. Another theory posits that gravitational interactions with other giant planets during the early formation of the solar system could have gradually altered Uranus's tilt. Yet this scenario would likely require a very specific chain of events to achieve the current orientation, and it doesn't fully explain the planet's current rotational dynamics. Some researchers have even suggested that Uranus could have experienced multiple smaller impacts, each contributing incrementally to its tilt. However, the likelihood of this occurring without disrupting the planet's overall structure seems quite low. Adding to the mystery, Uranus also has an unusual magnetic field that is tilted relative to its rotational axis, further complicating our understanding of its internal structure and history. The planet's odd orientation and the persistent questions about its formation make Uranus one of the most intriguing subjects for planetary scientists. Understanding the true cause behind Uranus's extreme axial tilt will require more detailed observations and perhaps even future missions to closely study this enigmatic ice giant. Until then, the exact reasons behind Uranus's sideways spin remain one of the most compelling unsolved mysteries of our solar system. The 10th mystery involves Venus geological activity. Venus, often referred to as Earth's twin due to its similar size and composition, is shrouded in thick clouds of sulfuric acid, making its surface difficult to observe directly. However, radar mapping has revealed intriguing features that suggest the planet might be geologically active. One of the most compelling pieces of evidence for ongoing volcanic activity on Venus comes from the detection of transient hotspots or thermal anomalies observed by the European Space Agency's Venus Express mission. These hotspots indicate areas where the surface temperature is significantly higher than the surrounding terrain, hinting at recent or ongoing lava flows. Another clue is the presence of features known as coronae, which are large circular structures thought to be formed by upwellings of molten rock from the mantle. The relatively young age of these structures suggests that Venus is still geologically active, Additionally, the changing levels of sulfur dioxide in Venus' atmosphere provide further evidence of potential volcanic activity. Sulfur dioxide is a gas commonly released by volcanic eruptions, and variations in its concentration could indicate recent eruptions or ongoing volcanic processes. Despite these tantalizing hints, confirming active volcanism on Venus remains a challenge. The extreme surface conditions, with temperatures hot enough to melt lead and crushing atmospheric pressure, make direct observation and exploration difficult. Future missions equipped with advanced instruments may provide the definitive evidence needed to confirm whether Venus is still geologically active. Understanding Venus volcanic activity is crucial for several reasons. It could provide insights into the planet's geological history, atmospheric evolution, and even its potential habitability in the distant past. Moreover, studying Venus volcanism might help us understand similar processes on Earth and other rocky planets. Until we can gather more data, the question of whether Venus is currently experiencing volcanic activity remains one of the most fascinating unsolved mysteries in our solar system, inviting further exploration and study. The 11th mystery involves the Kuiper Belt objects. Located beyond the orbit of Neptune, the Kuiper Belt is a vast region filled with icy bodies and dwarf planets. This distant part of our solar system remains largely unexplored, making it a treasure trove of mysteries. One of the biggest questions is the sheer diversity of objects found in the Kuiper Belt. Ranging from small icy rocks to larger bodies like Pluto and Eris, these objects vary widely in size, composition, and color. What processes led to such a variety in this distant realm? Another intriguing aspect is the origin and evolution of these objects. Many scientists believe that Kuiper Belt objects are remnants from the early solar system, offering a glimpse into its formation. Yet, the exact mechanisms that shape these objects and their current distribution are still unclear. The discovery of binary systems where two objects orbit each other adds another layer of complexity. How did these pairs form, and what do they tell us about the conditions in the early solar system? Additionally, the mysterious Planet 9, a hypothetical planet suggested by unusual orbits of some Kuiper Belt objects, raises further questions. If it exists, what is its impact on the Kuiper Belt and the solar system at large? The arrival of NASA's A New Horizons mission in the Kuiper Belt, especially its flyby of the object Arrokoth, has provided new insights but also more puzzles. Arrokoth's unusual shape and surface features challenge our understanding of how such bodies form and evolve. As we continue to study this distant region, the Kuiper Belt holds the promise of unlocking secrets that could reshape our knowledge of the solar system's history and dynamics. Future missions and observations may one day unravel the mysteries of these distant icy worlds, revealing new insights into the early solar system and the processes that govern its outermost regions. Until then, the Kuiper Belt remains one of the most enigmatic and intriguing areas of space for astronomers and planetary scientists. The 12th mystery involves the Pioneer Anomaly, a peculiar phenomenon observed in the trajectories of the Pioneer 10 and Pioneer 11 spacecraft. Launched in the early 1970s, these spacecraft were the first to venture beyond the asteroid belt and provide close-up images of Jupiter and Saturn. However, as they journeyed further into the outer reaches of the solar system, scientists noticed something strange. Both spacecraft were experiencing a small but consistent deviation from their expected paths. This deviation, known as the Pioneer Anomaly, puzzled scientists because it didn't align with our current understanding of physics. The anomaly was characterized by a slight, unexplained acceleration towards the Sun. Despite extensive efforts to account for factors such as gravitational influences from known celestial bodies, the pressure of sunlight, and even the heat emitted by the spacecraft themselves, the precise cause of this deviation remained elusive. Some researchers propose that the anomaly could be due to onboard thermal recoil forces, where heat radiated asymmetrically from the spacecraft might cause a tiny push. Others speculated about the possible influence of dark matter or modifications to our understanding of gravity at large distances. Despite these intriguing hypotheses, none provided a definitive explanation. The Pioneer anomaly highlights the challenges of accurately measuring and predicting spacecraft trajectories in the vastness of space. It serves as a reminder of how even small, unexpected observations can challenge established scientific theories and spur new lines of inquiry. While subsequent missions have not observed a similar phenomenon, the Pioneer anomaly remains a fascinating case study in the complexities of space exploration. It underscores the importance of continuous observation and the willingness to revisit and revise our theories in light of new data. As we continue to send spacecraft to the far reaches of the solar system and beyond, future missions may provide additional insights or even uncover new anomalies, further enriching our understanding of the cosmos. Until then, the Pioneer anomaly stands as one of the most intriguing unsolved mysteries in the history of space exploration, reminding us that the universe still holds many secrets waiting to be discovered. The 13th mystery involves the true nature of Oumuamua. In 2017, astronomers detected an unusual object passing through our solar system, named Oumuamua, which means scout or messenger in Hawaiian. This object was the first known interstellar visitor to our cosmic neighborhood. Unlike any comet or asteroid seen before, Oumuamua exhibited a peculiar elongated shape, resembling a cigar or pancake. What made it even more intriguing was its high speed and the fact that it didn't follow the typical gravitational path expected of an object from our solar system. At first, scientists thought Oumuamua was a comet, but it lacked a visible tail or the outgassing typically seen as comets approach the Sun. Others classified it as an asteroid, yet its unusual shape and extreme rotation didn't fit the bill. Theories began to emerge, with some even suggesting it might be an alien probe due to its unusual acceleration, which wasn't entirely explained by gravity alone. Instead of slowing down as it moved away from the Sun, Oumuamua appeared to accelerate slightly, sparking debates and further investigations. One leading hypothesis is that Oumuamua could be a fragment of a larger body that broke apart before entering our solar system. Another idea is that it's a type of comet whose outgassing wasn't visible to our instruments. There's also talk about it being a hydrogen iceberg, which might explain the lack of observed outgassing because hydrogen would be invisible in our telescopes. Despite these theories, none can fully explain all the observed characteristics of Oumuamua, leaving its true nature shrouded in mystery. As Oumuamua has already left our solar system, the opportunity to study it more closely has passed, adding to the enigma. Yet its discovery has opened our eyes to the possibilities of interstellar objects and the stories they carry from beyond our solar system. Future developments in astronomy may one day provide more clarity, but for now, the true nature of Oumuamua remains one of the most compelling unsolved mysteries of our solar system, inviting us to keep looking to the stars for answers. The 14th mystery involves Pluto's heart-shaped region known as Tombaugh Regio. This distinctive area, named after Pluto's discoverer Clyde Tombaugh, gained fame for its unique and visually striking appearance when the New Horizons spacecraft flew by Pluto in 2015. Tombaugh Regio is not just a pretty feature, it holds crucial clues about the dwarf planet's geology and atmospheric processes. One of the most fascinating aspects of Tombaugh Regio is its composition. The western lobe, called Sputnik Planisher, is a vast, icy plain primarily made of nitrogen ice with traces of methane and carbon monoxide. This composition hints at Pluto's complex geological history and the different materials present on its surface. What's truly puzzling is the apparent youth of this region. Unlike the heavily cratered areas around it, Sputnik Planisher shows almost no impact craters, suggesting it is geologically active and possibly less than 10 million years old. This raises questions about the forces capable of resurfacing Pluto so recently. Some scientists propose that convection within the nitrogen ice could be responsible, where the ice slowly churns and refreshes the surface. Another theory suggests that subsurface oceans, kept liquid by the heat from radioactive decay within Pluto's core, might be contributing to this activity. Adding to the intrigue are the cellular patterns observed on Sputnik Planisher's surface. These polygonal shapes, roughly 20 to 30 miles across, resemble convection cells seen in Earth's mantle, further hinting at dynamic processes underneath the ice. Moreover, this heart-shaped region has a significant impact on Pluto's atmosphere. The nitrogen ice sublimates during the day and refreezes at night, driving Pluto's thin atmosphere and contributing to complex weather patterns. The sheer diversity and activity observed in Tombaugh Regio challenge our understanding of what a dwarf planet can be. While Pluto was once thought to be a frozen, inert world, the discovery of Tombaugh Regio has revealed a place of surprising geological complexity and dynamism. As scientists continue to analyze the data from New Horizons, the mysteries of Pluto's heart-shaped region offer a profound reminder of the unexpected wonders that await us in our solar system's outskirts. The 15th mystery involves the Rings of Saturn. These magnificent rings are one of the most recognizable features in our solar system, yet despite their iconic status, their origins and age remain enigmatic. The rings are composed primarily of ice particles with a smattering of rocky debris and dust, collectively forming a delicate yet expansive structure that encircles the gas giant. One of the key questions scientists grapple with is, where did these rings come from? Some theories suggest that the rings are remnants of a moon or comet that was shattered by Saturn's powerful gravity. According to this hypothesis, the destruction of such a celestial body could have produced the debris that eventually formed the rings. Alternatively, it's possible that the rings are primordial, dating back to the formation of Saturn itself over 4-5 billion years ago. This would imply that the rings have persisted since the early days of the solar system, despite the dynamic environment they inhabit. Another intriguing aspect is the age of the rings. Are they ancient, having existed for billions of years, or are they relatively young, perhaps only a few 100 million years old? Recent data from the Cassini spacecraft, which orbited Saturn for over 13 years, suggests that the rings might be younger than previously thought. Based on the rate at which the rings are losing material to Saturn's atmosphere, some scientists estimate that they could be as young as 100 million years old. This relatively youthful age poses further questions. What event could have caused the formation of such prominent rings in the more recent geological past? The rings also display complex structures and variations in composition that hint at ongoing processes of both creation and destruction. For example, the presence of small moons embedded within the rings, known as moonlets, suggests that the rings are not static but are continuously interacting with Saturn's gravitational field. Furthermore, the dynamics within the rings, including the formation of gaps and the intricate braiding of ringlets, indicate a delicate balance shaped by gravitational forces from Saturn and its moons. Understanding the origins and age of Saturn's rings not only sheds light on the gas giant itself, but also provides broader insights into the processes that shape planetary ring systems throughout the galaxy. As future missions to Saturn and advanced telescope observations continue, we may eventually unravel the secrets behind these spectacular rings, offering a deeper appreciation of their beauty and complexity. Until then, the rings of Saturn remain a captivating mystery, emblematic of the wonders and unknowns that still await us in our exploration of the solar system. The 16th mystery involves the solar corona. This phenomenon has bewildered scientists for decades. The Sun's outer atmosphere, known as the corona, reaches temperatures of several million degrees Celsius, significantly hotter than the Sun's visible surface, or photosphere, which averages around 500 degrees Celsius. This counterintuitive temperature gradient raises the question, why is the corona so much hotter than the Sun's surface? One prominent theory is the role of magnetic waves, specifically Alfvén waves, which are thought to transport energy from the Sun's interior up to the corona. These waves travel along magnetic field lines and could deposit their energy in the outer atmosphere, heating it to extreme temperatures. However, detecting and measuring these waves has proven challenging, and the exact mechanisms of their energy transfer remain unclear. Another possibility involves magnetic reconnection. This process occurs when magnetic field lines break and reconnect, releasing tremendous amounts of energy. These explosive events could contribute to the heating of the corona, but they alone might not account for the sustained high temperatures observed. The solar wind, a stream of charged particles emanating from the corona, adds another layer to the mystery. While the solar wind's origins and acceleration are partially understood, its relationship with coronal heating is still under investigation. Could the processes driving this wind also play a role in the corona's intense heat? Recent observations from NASA's Parker Solar Probe and the European Space Agency's Solar Orbiter are providing new data, offering glimpses into the Sun's outer atmosphere at unprecedented proximity. These missions aim to answer critical questions about the transfer of energy and the role of magnetic fields in coronal heating. Understanding the solar corona is not just an academic pursuit. It has practical implications for space weather, which can affect satellite operations, GPS systems, and power grids on Earth. By unraveling the mystery of the corona's high temperatures, we might better predict solar storms and mitigate their impact on our technology-dependent society. Despite advances in solar physics, the exact reasons behind the corona's extreme heat remain elusive. As we continue to probe the Sun with advanced instruments and innovative missions, we hope to illuminate this captivating enigma, shedding light on a fundamental aspect of our closest star. Until then, the solar corona stands as a brilliant reminder of the Sun's many mysteries that beckon us to explore. The 17th mystery involves Mercurys Ice. Yes, you heard that right, ice on the planet closest to the Sun. Given Mercury's average daytime temperatures can soar to 430 degrees Celsius, the presence of ice seems almost impossible. Yet, in the permanently shadowed craters at Mercury's poles, scientists have detected significant deposits of water ice. These craters, shielded from the Sun's direct heat, maintain temperatures cold enough to preserve ice for potentially millions of years. NASA Messenger spacecraft confirmed these icy patches using radar and neutron spectroscopy, suggesting that ice could be mixed with organic materials. But how did this ice get there? One hypothesis is that comets or asteroids containing water crashed into Mercury, depositing ice in these shadowed regions. Another idea is that water molecules in Mercury's thin exosphere, a tenuous layer of atoms and molecules, might have migrated to the poles and condensed into ice. The reflective bright spots detected by radar raise more questions. How deep do these ice deposits go, and what role do Mercury's weak magnetic field and lack of atmosphere play in preserving them? Understanding the presence of ice on Mercury could also offer clues about similar processes on other airless bodies in our solar system, such as the Moon. This icy enigma challenges our understanding of how volatile substances can survive in extreme environments. As new missions to Mercury are planned, the secrets of its polar ice may soon be revealed, shedding light on one of the most surprising unsolved mysteries of our solar system. The 18th mystery involves the origin of Martian methane. The presence of methane on Mars has been a topic of much debate and intrigue among scientists. First detected in the early 2000s, this simple molecule has profound implications for our understanding of the red planet. methane can be produced by both geological and biological processes, which makes its presence on Mars particularly tantalizing. On Earth, a significant amount of methane is produced by living organisms, such as bacteria found in wetlands and the digestive systems of animals. This raises the exciting possibility that microbial life could exist on Mars, producing methane as a metabolic byproduct. However, there are also non-biological processes that can generate methane. For instance, it can be produced by chemical reactions between water and certain types of rock, a process known as serpentinization. Additionally, methane can be released from reservoirs trapped beneath the Martian surface, possibly accumulated from ancient volcanic activity. The detection of methane on Mars has been inconsistent and seasonal, adding to the mystery. NASA Curiosity rover and ESA's Mars Express orbiter have both detected spikes in methane concentrations, but these findings are not always corroborated by other instruments. The seasonal variations suggest that methane might be released in bursts, influenced by temperature changes or other environmental factors. One of the key questions is how long methane can persist in Mars' atmosphere before being broken down by ultraviolet radiation. On Earth, methane lasts about a decade before it is destroyed by atmospheric processes, but on Mars, this timescale could be shorter. This implies that the methane detected must have a relatively recent source. The implications of these findings are significant. If the methane is indeed of biological origin, it would be a groundbreaking discovery, providing the first evidence of life beyond Earth. On the other hand, understanding geological sources of methane would offer insights into Mars' internal processes and its potential for past habitability. Future missions, such as ESA's ExoMars rover, aim to drill beneath the Martian surface to directly search for potential biological markers and better understand the sources of methane. As we continue to study Mars with increasingly sophisticated instruments, we hope to unravel the mystery of its methane, potentially answering one of the most profound questions in planetary science: is there life on Mars? Until then, the origin of Martian methane remains an unsolved enigma, inviting us to explore further and deepen our knowledge of the Red Planet. The 19th mystery involves the asteroid belt between Mars and Jupiter. Scientists have long puzzled over why the asteroid belt contains far less mass than expected. This region, filled with rocky remnants from the early solar system, should by all accounts hold enough material to form a planet. However, the total mass of all the objects in the asteroid belt is only about 4% of the Moon's mass. Why is this the case? One prevailing theory is that Jupiter's immense gravitational influence played a significant role. During the early formation of the solar system, Jupiter's strong gravity could have prevented the material in the asteroid belt from coalescing into a larger body. This gravitational disruption would have stirred up the region, causing frequent collisions that fragmented the material into smaller pieces rather than allowing it to accumulate into a planet. Another possibility is that much of the asteroid belt's original mass was ejected from the region altogether. As Jupiter and the other giant planets migrated to their current positions, their gravitational forces could have booted many objects out of the asteroid belt, sending them either into the inner solar system or out into the distant reaches beyond Neptune. Additionally, some of the mass in the asteroid belt could have been absorbed by the planets themselves. Early in the solar system's history, planets were still growing by accreting material from their surroundings, and it's possible that Mars and Jupiter absorbed a significant amount of the mass that might otherwise have remained in the asteroid belt. There's also the idea that the solar wind and radiation pressure from the Sun could have gradually pushed smaller particles out of the asteroid belt over billions of years. This process, known as Poynting-Robertson drag, causes dust and small debris to slowly spiral inward toward the Sun, effectively reducing the overall mass of the asteroid belt. Despite these theories, the exact reasons behind the missing mass remain elusive. Further exploration and study of the asteroid belt, including missions like NASA's upcoming Psyche mission to a unique metallic asteroid, may provide more clues about its history and the processes that shaped it. Understanding why the asteroid belt holds so little mass compared to what was expected not only illuminates the dynamics of our solar system's formation, but also offers insights into the behavior of planetary systems around other stars. Until we uncover more definitive answers, the mystery of the asteroid belt's missing mass continues to challenge and intrigue scientists, highlighting the complexities of the cosmic forces at play in our solar system. The 20th mystery involves the faint young sun paradox. This perplexing enigma delves into the question of how early Earth stayed warm enough to support liquid water and life, even when the sun was significantly fainter than it is today. According to stellar evolution models, the sun's luminosity was about 30% less intense during the early stages of the solar system, around 4 billion years ago. This level of solar output should have left Earth frozen and inhospitable. Yet geological evidence clearly shows that early Earth had liquid water and relatively moderate temperatures. So how did our planet defy the odds? One theory suggests that Earth's atmosphere was much thicker and richer in greenhouse gases like carbon dioxide and methane, which could have trapped enough heat to keep the planet warm. These gases would have created a strong greenhouse effect counteracting the weaker solar radiation. But the exact levels of these gases required to maintain such temperatures are still debated. Another idea involves the possibility of a lower albedo, meaning Earth's surface and clouds reflected less sunlight back into space. This would have allowed more solar energy to be absorbed, helping to warm the planet. However, this explanation alone may not account for the observed temperatures. The role of volcanic activity is also considered significant. Frequent volcanic eruptions could have released large amounts of greenhouse gases into the atmosphere, maintaining higher temperatures. Additionally, the internal heat generated by the planet itself through geothermal processes might have contributed to warming the surface. Some researchers propose more exotic solutions, such as the influence of cosmic rays on cloud formation, which could have altered the climate in ways we don't fully understand yet. Despite numerous theories, a consensus on the precise mechanisms that resolved the faint young sun paradox remains elusive. As we continue to study the early conditions of Earth and refine our climate models, we hope to piece together the puzzle of how our planet stayed warm in the face of a faint young sun. This mystery not only has implications for understanding Earth's past, but also informs our search for habitable conditions on exoplanets around other stars. The faint young sun paradox is a fascinating reminder of the delicate balance of factors that sustain life and the complex interplay of cosmic and geological forces that have shaped our world. Until we uncover more definitive answers, it remains one of the most compelling unsolved mysteries in planetary science, inviting us to explore further and deepen our understanding of Earth's early climate and the potential for life elsewhere in the universe. The 21st mystery involves the moons of Jupiter. Jupiter, the largest planet in our solar system, boasts an astonishing array of moons, each with its own intriguing characteristics. With over 79 known moons, Jupiter presents a fascinating and complex system that continues to baffle scientists. Among these moons, the four largest, known as the Galilean moons, Io, Europa, Ganymede, and Callisto, are particularly enigmatic. Starting with Io, this moon is the most volcanically active body in the solar system. Its surface is dotted with hundreds of volcanoes, some of which erupt with lava fountains reaching heights of over 200 miles. The source of this volcanic activity is believed to be the intense tidal forces exerted by Jupiter's gravity, which generate internal friction and heat within Io. However, the exact mechanisms driving Io's extraordinary volcanism and the composition of its subsurface layers remain mysteries. Is there a subsurface magma ocean? And if so, how does it compare to Earth's own volcanic processes? Europa, another of Jupiter's moons, is equally captivating but for entirely different reasons. This icy world is believed to harbor a subsurface ocean beneath its frozen crust, potentially containing more water than all of Earth's oceans combined. The presence of this ocean raises the tantalizing possibility of life. Recent observations have detected plumes of water vapor erupting from Europa's surface, similar to the plumes seen on Saturn's moon Enceladus. What drives these plumes, and what could they reveal about the ocean below? Furthermore, why does Europa's icy surface exhibit so few impact craters, suggesting a relatively young and geologically active surface? Ganymede, the largest moon in the solar system, surpasses even Mercury in size. It is unique for having its own magnetic field, a feature not found on any other moon. Ganymede's magnetic field creates auroras near its poles, influenced by Jupiter's powerful magnetosphere. This moon's surface is a mix of two types of terrain: highly cratered, darker regions and lighter, grooved areas that indicate tectonic activity. What processes are responsible for Ganymede's diverse landscape, and what is the source of its magnetic field? Could there be a liquid iron or salty water layer beneath its surface that generates this magnetic phenomenon? Callisto, the outermost of the Galilean moons, presents yet another set of puzzles. It is heavily cratered, suggesting an ancient and relatively unchanged surface. Unlike its sibling moons, Callisto shows little evidence of internal geological activity. However, data from the Galileo spacecraft suggests the presence of a subsurface ocean, similar to Europa. If so, why does Callisto show no signs of more recent geological changes? What can this tell us about the conditions required to maintain liquid water beneath an icy crust? Beyond the Galilean moons, Jupiter's smaller and more recently discovered moons also pose questions. Some of these moons have highly irregular shapes and orbits, likely captured asteroids or remnants of larger bodies that broke apart. Understanding their origins and histories can provide insights into the complex gravitational interactions within the Jupiter system. The mysteries of Jupiter's moons highlight the incredible diversity and dynamism of planetary bodies in our solar system. As future missions such as NASA Europa Clipper and ESA's Jupiter Icy Moons Explorer aim to explore these moons in greater detail, we hope to uncover the secrets that lie beneath their surfaces. Each moon holds clues about the processes that shape planetary systems and the potential for life beyond Earth. The moons of Jupiter, with their unique and varied characteristics, continue to captivate our imagination and drive our quest for knowledge, reminding us of the vast and wondrous mysteries that await our exploration in the cosmic neighborhood. The 22nd mystery involves the elusive Planet 9. For years, astronomers have speculated about the existence of a ninth planet lurking in the far reaches of our solar system. The idea gained traction in 2016 when astronomers Konstantin Batygin and Mike Brown from Caltech presented compelling evidence based on the peculiar orbits of several distant objects in the Kuiper Belt. These trans-Neptunian objects, or TNO, exhibit orbits that are oddly clustered and tilted, suggesting the gravitational influence of an unseen massive body. Planet 9 is hypothesized to be about 10 times the mass of Earth and to orbit the Sun at a distance of approximately 400 to 800 astronomical units, far beyond the orbit of Neptune. This hypothetical planet could take between 10,000 to 20,000 years to complete one orbit around the Sun. What could have led to the formation of such a distant, massive planet? One theory suggests that Planet 9 could be a rogue planet captured by our solar system's gravity. Another possibility is that it formed closer to the Sun and was flung outwards by gravitational interactions with Jupiter and Saturn during the early days of the solar system. The search for Planet 9 poses significant challenges due to its extreme distance and faintness. Despite extensive surveys of the sky using powerful telescopes, Planet 9 has yet to be directly observed. The vast area it could inhabit requires painstaking and meticulous searches. Some scientists even speculate that Planet 9 could be a primordial black hole, a small but dense object formed in the early universe, adding another layer of intrigue to this mystery. If Planet 9 exists, it could help explain not just the orbits of TNOs, but also peculiarities in the tilt of the solar system's plane and the distribution of other distant objects. Discovering Planet 9 would be a monumental achievement, reshaping our understanding of the solar system's architecture and formation. Until then, the hunt for Planet 9 continues, drawing astronomers into the dark, distant corners of our cosmic neighborhood. In summary, the mysteries of our solar system are not just puzzles for scientists, but invitations for all of us to ponder the vast unknowns still waiting to be discovered. From the enigmatic disappearance of planet Vulcan to the strange hexagon on Saturn, each mystery reveals the uncharted territories of our cosmic neighborhood. Mars' recurrent slope lineae challenge our understanding of water and geology on the red planet, while Jupiter's great red spot and Enceladus Mysterious Plumes hint at the dynamic and potentially life-sustaining processes beyond Earth. The dark side of the Moon and Neptune's vanishing storms show us how much we have yet to learn about even our closest neighbors. Uranus's extreme axial tilt and Venus' possible geological activity highlight the dramatic and violent histories that shape planetary bodies. The Kuiper Belt and the Pioneer Anomaly remind us that the outer reaches of our solar system hold secrets about the early formation of our celestial home. The true nature of Oumuamua and Pluto's heart-shaped Tombaugh Regio challenge our perceptions of what lies beyond our immediate glance. Saturn's rings, the solar corona, and Mercury's unexpected ice deposits showcase the delicate balances and extreme conditions that make each celestial body unique. The methane on Mars and the asteroid belt between Mars and Jupiter reflect the intricate and minute details that carry significant implications about the possibilities of life and the processes of planetary formation. The faint young sun paradox and Jupiter's moons like Europa and Ganymede push us to rethink the conditions for habitability and the forces that shape our solar system. Lastly, the elusive Planet 9 beckons us to consider the unseen influences that govern the movements of celestial objects far beyond our immediate view. These mysteries invite us not just to look but to wonder and seek answers, reaffirming that our journey to understand the cosmos is far from complete. So as we continue to explore and discover, let's keep our curiosity alive, knowing that each question brings us one step closer to unraveling the profound secrets of our solar system. Thank you for joining us on this journey through the unsolved mysteries of the solar system. Don't forget to like this video, subscribe to our channel, and hit the notification bell so you don't miss out on our next exploration into the unknown. Keep looking up because the universe always has more to reveal.